Hello, so welcome back. Today we will be doing on the chapter of ionic compound and covalent compound, and we'll also be touching on metallic bonding. What we're going to do is we're going to analyze the properties that each of these compounds possess, and we will go in depth in explaining why is the properties like that. So let's first take a look at ionic compound. Remember, ionic compound is a bond between a positive ion and negative ion in a giant ionic lattice. It looks something like this. It's actually a cubic structure. As you can see, that is plus minus plus minus plus minus in alternate fashion. As a result, there will be a ratio of 1:1. If you have counted, there will be a total of 6:6 plus and 6:6 minus ions. And if you have a 2:1 ratio, then it will be another compound such as magnesium chloride or other things that have a charge of 2. And also now we will take a look at the physical properties of all ionic compound, or most ionic compound I say. For ionic compound, first of all, you must know that it is soluble in water, insoluble in solvent. This is the first point. Second point, it has high melting and high boiling point. This is a very important point because you need to understand why do they have a high melting and high boiling. Strong ionic bonds between the ions. As a result of that, it resulted in a large amount of heat energy is required to overcome it, hence causing a high melting and high boiling. So the few keywords that you need to have in your answer is ionic bonds between the ions, hence a lot of heat energy is required to overcome it. And next we will talk about is conductivity. Ionic compound conducts electricity only in two states, molten and aqueous. So it does not conduct in solid, gas or liquid. It does conduct in liquid because liquid is molten. It does not conduct in solid and gas. The reason why is because that in solid and gas, they do not have mobile ions that can move about to conduct electricity. While in aqueous and molten, there will be mobile ion. So in this context, the keyword is mobile ion. So next, we will be taking a look at covalent compounds. Covalent compounds mainly exist as two types. First, as simple molecular substance or as a giant molecular structure. For simple molecular substance, there are such as HCl. Bear in mind that HCl must be in liquid state, and also oxygen, carbon dioxide. All these are simple molecular structures. The first property that it has is that it's insoluble in water but soluble in organic solvent. Organic solvent is such as this. And it has low melting and low boiling. The reason is because the molecules, so for example, the oxygen molecules, this is one molecule, then there's another molecule. Between these two molecules, there's a force, and this force is called the weak van der Waals force of attraction. And as a result of this force, a small amount of heat energy is required to actually overcome it. This resulted in it having a low melting and low boiling. And we also take a look at its conductivity. It does not conduct electricity as ionic compounds. This is because there's no mobile ions. Next, we'll be looking at giant molecular structure, or we also can call it micromolecular structures. Such examples are diamond. For diamond, is actually made of purely carbon atoms, and this is the structure diamond it is. And the reason, and one of the very common properties that most of you will know is that diamond is very strong and hard. It's used as cutter, it's diamond cutter, can cut a lot of stuff. The reason for it to be strong and hard is because one carbon atoms are joined with 4 other carbon atoms like this by a strong covalent bond. So the keyword here is strong covalent bond, and it's also in a tetrahedral structure. So these are the 2 points that resulted in it being strong and hard. Next, it also has high melting and high boiling. The reason is because of the strong covalent. Because if there's a strong covalent, a lot of heat energy is required to overcome it. And last but not least, it does not conduct electricity because there's no mobile ions or electrons. Now we will look at the next giant molecular structure, which is graphite. Graphite is something you can find in your pencil lab. I mean, not unless you have a pure graphite pencil, but you know a certain percentage of it. Graphite has a very unique property. First of all, graphite is also made of carbon. Every single atom here are made of carbon. It has a very unique property. It conducts electricity The reason it conducts electricity unlike diamond is because each carbon atom now is only bonded to 3 other carbon atoms, hence leaving a spare valence electron to move freely throughout the structure and conduct electricity. It has also high melting and high boiling due to its strong covalent bonds between the atoms. Remember, it's between the carbon atoms. And last property is that it's soft and slippery because each hexagonal ring, as you can see, this is a hexagonal ring, is separated by weak van der Waals force. Hence, it's easy for you to slide it over. Now, let's take a look at the last part of today's chapter, which is on metallic bond. Metallic bond is basically for metal. Metallic bond means there is a force between a sea of delocalized electron and the positive ion. As you can see, let's talk about sodium for example. Sodium is a piece of metal. So if it's a metal, it's going to be a positive ion and it's surrounded by one delocalized electron. So with the positive ion plus the electron, you get sodium. If you take away the electron, you will get sodium plus, which is the positive ion. So with that understanding, such electron is able to move freely throughout the structure, hence making it a good conductor of electricity. And also, metals are generally malleable and ductile. The reason is because of the orderly arrangement of the positive ion. So it's easy for you to slide and actually to bang it. It also has high melting and high boiling due to its strong metallic bond. And last, I would like to recap a bit. For diamond that I previously mentioned, it has similar physical properties as silicon oxide. With that, I come to the end of my lesson. Hopefully, you guys have help you guys to refresh yourself, and please keep on revising. Thank you.